Good day, everybody. Today we're going to talk more about graphing using exponential growth and decay functions. So this is what we did last time. We learned these shapes. So we had these growth functions, and let me go ahead and just write out what we did. Okay, so we had a graph, and we were given an equation like y is equal to 2 to the power of x minus 1 plus 2 or something like that. But I'm going to take off these numbers and we'll keep it simple while I talk about this. So a growth function, it starts right above the axis, and it kind of goes in a straight line, and then it goes up really quickly. Okay, that's the shape of our graph. So when we graph these, we know that that's what that looks like. And this is because the base is bigger than or larger than 1. Okay, so whenever it's right here, whenever this number is larger than 1, it's going to make this shape, and if it's less than 1, it's going to make the other shape we saw. Another thing is that we always have an asymptote, meaning that right here on the x-axis is called an asymptote. Okay, so with this shape of the graph, an asymptote, what that means is it stops the graph from going down. So as it approaches this asymptote, instead of going down, it ends up just going kind of to the left forever. Okay, so if you want to say it's a line that cannot be crossed. And when we graph, we always usually start with the asymptote. And so with the domain and range on this, it's going to go left forever and right forever. So the domain on this, so domain on a growth function is always all real numbers. Okay, so you can have anything. The range does have a limit. So it doesn't go down forever because the asymptote makes it go left at this value, at the asymptote value. So at 0 in this graph, it'll go left forever, so it stops going down, but it'll always keep going up. And that is our domain and range. And so this right here, this number right here, for our range is always our asymptote. Okay, and that's why the asymptote is really important. Is to find the range, you just need to know your asymptote, and you're good. What does decay look like? Decay looks like the same thing. Okay, so here's decay, and it has an asymptote too, right there. It's our asymptote. Okay, and then the reason why this is happening is because the base, this base, is less than 1. Okay, and then the domain and range is the same thing. You got your left forever, you got your right forever, and your asymptote. So domain and range is the same thing. So now we're ready to graph. And so step one, we're going to graph the asymptote. Okay, that's step one. The asymptote is always this number right here. It's the +1. So when I make my graph here, at 1, we're going to have an asymptote. Okay. Step 2 is going to be a table of values. So we have an x and y table, and what we're always going to do is, let's see here, let's do blue, is this number right here, we're going to turn into a 0. Oops, sorry, let me make a better line. Okay, so we're going to turn this into a 0, right? So it's -2, so I'm going to write +2, and then we're going to go 1 above and 1 below. That's how we're going to do that. And then we're going to fill this out. Sometimes we can use a calculator pretty well, but if we don't have a calculator, we can do it by hand. So that makes -1. Okay. Now, when we have a negative power, it just becomes a fraction. So it just switches upside down. So we get 1 1/3. Okay. Then we're going to do the same thing for 2. So I'm going to erase all this. And we're going to do the same thing 3 to the 0 power is 1. 1 plus 1 is 2. Then we're going to do the same thing, this time with 3. So we get 3 to the 1 plus 1, which is 3 plus 1, which is 4. Then we're going to plot our points and draw our shape. So step 3, plot points, and then draw shape. Okay, so we have points 1 and 1/3, so it would be like right there. Oops. Okay, then we have 2, 2, and we have 3, 4. And then we're going to draw the shape. So the shape will follow this dashed line and then go straight up like that. Fantastic. The domain is always the same. Domain is all real numbers because we can go left and right forever. The range right here will be an infinity, but again our asymptote, right? I'm going to actually just write the 1. Sorry. It stops at 1, and that's because that's the asymptote. Okay, and that's how you graph those. It's actually a nice graph. That's how you get an A. Okay. We're going to be graphing this one. Same concept, same steps here. So we have our asymptote at -3. So I'm going to already make my graph and plot that. So 1, 2, 3, and we can already visualize our graph. Okay. So this is a decay because it's less than 1, so we know it's going to go like this. So we can actually just trace it out if you want to see, right? But we want an A. So then we're going to do an XY table of values where I'm going to put a -4 there. I'm going to highlight this here and highlight that because I made it a 0. Okay, remember that zeros, they'll never go away. This idea of zeros, we'll do a million of them. So we're going to do one above and one below, and then we're going to find this out. Okay, now I can use a calculator here. So in the calculator I put 1 divided by 2, parenthesis, power, parenthesis, -5, plus 4, and then -3. And then I would hit enter. Now if I did that, I'd get -1. Okay, now when I do the other one, I'm going to get -2. When I do the other one, when I put -3 in there, I'm going to get -2 and a half. Okay, so then at -5, did I do my math right? Let me check my math. Yes, so my math is right. So we have -5, 1, 2, 3, 4, 5, and -1. -4 and -2, and then -3 and -2.5. And we're going to follow this line to the right because it follows asymptote, and then it's going to go straight up. Perfect graph, awesome, awesome shape. Domain is all real numbers. Range is the asymptote again. So let's see here, -3, and I'm going to highlight it in green so you know it goes together. Okay. So, because it stops going down at -3 and ends up going right forever. All right, so now we're going to actually use this information in real-world context, okay? So all these graphs represent something that's going to happen in real life, and we're going to talk about that now. So in real life, we usually have a formula we're going to use here. So if I can move around here, here we go, there we go. So we're going to have a formula we're going to use here. So there's a growth formula. So when we invest money or things are increasing fast, there's a formula here, and it's called A is equal to P parenthesis 1 plus R over N. Okay, and I changed colors on purpose, and I'll show you why in a minute. N power times T power. And I've kind of run out of colors here. Let's see here. What else can I do? Let's do purple for T. Okay, so let's go back to red. So A is the answer. That's the answer we're looking for after we make an investment or whatever. P is our starting value. So how much money are we going to invest, or how much medication I took, or whatever. R is our percent as a decimal. N is how many times are you computing your interest. So if you're a credit card company, it would be every day. So how often you, not often, you N, not a Y, and you compute, okay? Because you'll compute your interest at different intervals. Sometimes it's every year, every month, and so that's how often you compute it. And then you have another one there. And then T is usually time in years, or if the time changes, it's time, okay? Sometimes it's hourly, like if you're doing bacteria, sometimes it's minutes or hours that you use. But that's the values, and so you just kind of plug and play them. Okay, and then the decay formula is the same thing. A is equal to P1 minus the rate to the power of T. Notice the decay has no N because usually it's assumed 1. So notice the decay is the same formula, just with no N's. All right, so we're going to do the formula here. So let's go ahead and write it. So A is equal to, this is a growth formula. We're going to invest some money here. The principal of 1 plus R over N to the power of N to the T. Okay? Then we're going to put this all in and then just hit enter in our calculators here. So the answer is going to be our principal. Okay? So let's get a highlighter here. Highlighter. Ooh, red's really hard to see. But there's red. So our principal initial amount is 8,000 there. I'm going to have to make another video. We're going to run out of time on this one. 8,000. And then we have 1 plus. Then the rate is 3%. So we have 3% right there. Let me get my blue one out. 3%. So it'd be 0.3. Our N is compounded annually, so annually means 1. And then our number of years, what I did purple for years, that's right. Our years here is 6 years, so this would be 6. And then that's all in the calculator here. So let's get the calculator out and put that in there. Let me do that. Okay, so notice here that I put this in already, so it kind of like flash jumped, right? So we have 8,000, that I put 8,000 here, and then I have parenthesis 1 plus, parenthesis 1 plus. Now remember we put the parentheses around our fraction, like I did here. Then notice I have 2 parentheses, one for the fraction and one for the problem. If you forget a parenthesis, you will get a wrong answer. Power button. Remember how last time we talked about putting the parentheses in the exponent, so we do it again. The exponent gets put in parentheses. I hit enter, and then after 6 years at a 3% rate, we've now made $1,500, or $9,552.41. So $9,552.41. Okay. And then you're going to do the same thing for the rest of these problems. Just monthly means 12, and quarterly means 4. And then you're going to put these numbers in and get those numbers out, okay, using your calculator. Same process. So again, I'll just write it out, but I won't use the calculator here. So it's 8,000 is the same number. 1 plus our interest rate change, so it'll be 0.07 over 12, because it's 12 now is the monthly. That's what it means, 12. And then 12 times 6, okay? So, and then you just put it in the calculator the same way and hit enter. And then you're going to get your number. Same thing here for this one. We want the answer to when we invest $8,000 and then we do 1 plus the interest rate. So 12 is a little different. Notice it's not 0.0 anymore. It's 0.12 over quarterly is 4, and then 4 times 6, because 6 is the years, okay? And then you're going to hit enter on that one. All right, so I'm actually out of time on this video. I'm going to make another video that goes over the rest of these problems, and then we'll be done.